Good day, students. On this clip, we're going to be going over two examples on right triangle trig. So let's go ahead and write down the instruction for the examples. Find the exact value. Find the exact value of the other five trig functions with the given trig function in standard position. All right, so number one, we're going to consider the trig function cotangent theta equals 12 over 5, and theta is going to be located between negative pi. So negative pi is less than theta, and theta is less than negative pi over 2. All right, so in order to find the other five trig functions, it's good to construct a right triangle in standard position, and then we can use SOHCAHTOA to finish the problem off. So let's write this down, SOHCAHTOA. All right, so this is, we know what the S, the C, and the T mean, sine, cosine, and tangent. All right, so we do not have cotangent here. So how can I transform this to match one of these? Well, I know that if cotangent theta is 12 over 5, the reciprocal of that is tan, and tan is going to be 5 over 12. All right, so from TOA, I know that the opposite is the numerator, so 5 is the opposite. And then the denominator is the adjacent from TOA, so 12 is the adjacent. All right, so let's go ahead and draw a triangle within this in this quadrant in standard position with the opposite of 5 and the adjacent of 12. All right, so let's create our coordinate system. So there goes my y, and there goes my x-axis. Notice I know it's in quadrant 3, that's why my quadrant 3 is the biggest, so I'm going to be going in a negative direction since these two angles are negative. So 0, negative, you go down. So 0, negative pi over 2, and this is going to be negative pi. So remember, the angle in standard position is going to look like this. Remember, theta is your reference angle, always starts from the nearest x-axis, and your triangle must always sit on the x-axis also. All right, so your triangle should look like that, not drawn to scale. This is just a sketch. So this is theta right here. Okay. All right, so now that we have the triangle drawn, we have to remember that if you go left on your x-axis, this is going to be negative, and if you go down on your y, this is going to be negative also. All right, so let's populate the side measures that we know. The opposite is the side opposite this angle. So if I go across like this is the opposite, and the opposite is 5. All right, this is, oh, because it's negative, since we're going down, I'm sorry, it's supposed to be negative 5. And then the adjacent, we're going to the left, so it's going to be negative also on the x direction. The adjacent is 12, so we have negative 12 as my adjacent. If you notice, my hypotenuse is missing in this problem. So how do we find it? Since this is a right triangle, we can use the Pythagorean theorem to figure out what the hypotenuse is. So I'm going to use a trig variation of the Pythagorean theorem, which is adjacent square plus opposite square equals hypotenuse square. This is the same thing as a square plus b square equals c square. All right. So let's plug in the values we know. So adjacent is negative 12, so we'll have negative 12 square plus the opposite is negative 5 square equals h square. All right, let's get h by itself. All right, we'll square 12. If we square 12, we get 144. Square 5, you get 25 equals h squared. All right, add this 2, you have 169 equals h squared. To get h, you root both sides. So h equals 13. All right, so we know what our hypotenuse is. The hypotenuse is 13. All right, now we can use SOHCAHTOA and its reciprocals to figure out what the other 6 trig ratios are. So let's go ahead and figure them out. So let's start with sine. Sine theta is opposite of a hypotenuse from SO. Opposite is -5, hypotenuse is 13. The reciprocal of sine is cosecant. All right, so cosecant theta is the hypotenuse over the opposite. All right, so cosecant is going to be -13/5. Now the next trig function, we're going to use ka. Ka is cosine. Cosine theta is adjacent over hypotenuse. The adjacent is -12, and the hypotenuse is 13. The reciprocal of cosine is secant. Secant theta is hypotenuse over adjacent. Hypotenuse is 13, and adjacent is -12. So there goes your secant right there. Next, we have tan from TOA. Tan theta, we already know what that is. Opposite of adjacent is going to be 5/12. And last but not the least, the reciprocal of tan is cotangent. Cotangent theta is adjacent over opposite, which is 12/5. All right, so let's go ahead and list our 6 trig ratios. Sine theta is -5/13. Cosecant theta is -13/5. Cosine theta is -12/13. Secant theta is 13/12, -13/12. Tan theta is 5/12, and cotangent theta is 12/5. All right, so there goes your 6 trig ratios. Actually, it's 5 of them because we were given cotangent before. Cotangent was 12/5. All right. Now let's go ahead and consider question number 2. So for question 2, same procedure, but in this case we have cosine theta equals -3/7, and we have 90 degrees is less than theta, and theta is less than 180 degrees. All right. So let's go ahead and draw the triangle in standard position with this information. We're going to be using SOHCAHTOA first. SOHCAHTOA. So let's see. This is cosine, right? So what does ka tell me? Ka tells me that cosine is adjacent of a hypotenuse. So cosine theta is -3/7. That basically means this, the numerator in ka is the adjacent, and the denominator in ka means that 7 is the hypotenuse. Okay? All right, so let's draw a triangle. Remember, we're between 90 and 180, and that's going to be in quadrant number 2. So I'm going to make that a little bit bigger than the rest. So construct your coordinate system. All right, now note that let's put in the degree measures first, and then we'll talk about the sign next. This is 0. Since it's positive, we're going to be going counterclockwise. These two measures are positive, so 0, 90, 180. Now, our triangle is going to be in standard position, so it's going to look like this. It's going to be in quadrant 2, and you know that the reference angle always starts from your nearest x-axis, right, theta, and that means that our triangle has to sit on the x-axis like this. All right, this is not a done to scale, just a sketch. So there goes your angle. All right, and now going to the left direction for x means that x is going to be negative, and when we go upwards on the y, basically means that y is going to be positive. All right, so let's keep that in mind. Okay, now this is theta. That means that the angle opposite, the side opposite the angle is your opposite. This is opposite right here. We do not know what opposite is. This side right here is the adjacent. The adjacent is -3 because you're going to the left. And then your hypotenuse h is 7. All right, so now let's figure out what O is using right triangle trig so that we can finish the problem off. So we're going to use the Pythagorean theorem. A squared plus O squared equals h squared. So A is -3. -3 squared plus O squared equals 7 squared. All right, so let's work this out. -3 squared is 9 plus O squared equals 7 squared is 49. So what we're going to do is subtract 7 from both sides. So subtract 9 from both sides, subtract 9. And what we'll have is O squared equals 40. All right, to get O by itself, you root both sides. And you have O equals root 40. Now the question is, can root 40 be simplified? Well, let's see. Let's put it on the side here. Root 40. I can take out 2. Take out prime factors. You're left with 20. Take out another 2. You're left with 10. Take out 2. You're left with 5. Now, only factors that repeat, those are the ones you can take the square root of, right? So these two 2's is 2 square. The square root of 2 square is 2. So these two 2's comes out of the radical of the 2 because the square root of 4 is 2. These 2 and 5 do not repeat, so they remain under the radical. So this becomes 2. These two 2's come out as a 2 root. The product of 2 and 5 is 10. All right, so root 40 is 2 root 10. So our opposite in this case is 2 root 10. All right, so let's go ahead and put that back into the triangle. Our opposite is 2 root 10. Now we're ready to figure out all 6 trig ratios. All right? Okay, so let's do it. Using SOHCAHTOA, starting from sine theta is opposite of a hypotenuse. From opposite is 2 root 10, and the hypotenuse is 7. So if sine is opposite of a hypotenuse, is reciprocal as cosecant, right? Cosecant is going to be hypotenuse over opposite, which is 7 over 2 root 10. But we cannot have a radical in the denominator, so we have to rationalize the denominator. So what does that mean? You multiply the numerator and the denominator by this radical term right here, root 10. So that yields 7 root 10. In the denominator, we're going to have 2 times, root 10 times root 10 is just 10, right? So 2 times 10 is 20. So there goes cosecant. Now cosine theta is adjacent over hypotenuse. Let's try that again. Cosine theta is adjacent over hypotenuse. Now the adjacent is -3, hypotenuse is 7. So it's going to be -3 over 7. We already knew that from the problem. It's reciprocal of secant. Secant theta is hypotenuse over adjacent. So hypotenuse over adjacent is going to be the reciprocal of that, which is 7 over -3. All right, I can put the negative here. And then the last two, tan and cotangent. Tan from TOA, tan theta is opposite over adjacent, or in SOHCAHTOA. Opposite is 2 root 10, and the adjacent is -3. Now the reciprocal of tan is cotangent, so cotangent theta is adjacent over opposite. So adjacent is -3, opposite is 2 root 10. So we cannot have a radical in the denominator, so we're going to rationalize that. So root 10 top and bottom. So now that's going to give me -3 root 10 over root 10 times root 10 is 10, as mentioned earlier. 2 times 10 is 20. So there goes your cotangent. All right, now let's go ahead and organize all our answers in a nice list. Sine theta. Sine theta is 2 root 10 over 7. its reciprocal cosecant, cosecant theta, is 7 root 10 over 20. 7 root 10 over 20. And then cosine theta, cosine is negative 3 over 7. And its reciprocal secant, secant theta is negative 7 over 3. Two more. Tan theta is opposite over adjacent. We figured that out to 2 root 10 over 3. Actually negative. And then cotangent theta is negative 3 root 10 over 20. All right, so there goes our 6 trig ratios, technically 5, because we already knew cosine before in an organized list. So there you have it. But thanks so much for taking time to watch this presentation. Feel free to subscribe to my channel by clicking up here. Please post a comment to tell me what you think. I really appreciate it. More clips can be found on mygoodserve.com. Thanks again and have a wonderful day.